Math lesson number 25. Joint and combined variations. Joint variation is a variation where a quantity varies as the product of two or more other quantities. So the formula y is equal to k zx, wherein k must not be equal to 0. K is the constant of variation. So a real example of this is area of the rectangle. A is equal to length times width. Let's have examples. Number 1. Find the equation of the variation where y varies jointly as x and z, and y is equal to 32 when x is equal to 4 and z is equal to 2. So in this case, an indication that this is a joint variation is this statement, varies jointly. Now, let's go back to the formula, y is equal to kxz. So, as you can see, y is equal to 32, x is equal to 4, and z is equal to 2. So, we will substitute 32 to y, and then 4 to x, and then 2 to z. Now, simplifying that, we have 32 is equal to k times 8, because 4 times 2 is 8. Therefore, k is equal to 32 over 8. K is equal to 4. And this 4 is the constant of variation. Now, since the formula is y is equal to kxz, and we know that k is equal to 4, then the equation of the variation is, we will substitute 4 to k, that will be y is equal to 4xz. Number 2. If y is directly proportional to the product of x and z, and y is equal to 60 when x is equal to 5 and z is equal to 4, find y when x is equal to 3 and z is equal to 7. So another indication that this is a joint variation is this statement, directly proportional to the product of. So that's an indication that this is a joint variation. So again, the formula y is equal to kxz. We substitute 60 to y, so 60, and then 5 to x, 4 to z. Now, we simplify k times 5 times 4, that's k times 20. And then, in order to get k, we need to divide both sides by 20. So that will be 60 over 20 is equal to 3. And this 3 is the constant of variation. Now, we will substitute this 3 to k in our formula. So, it will become y is equal to 3xz. And this will be the equation of the variation. Now, we will use this to solve the problem. So, find y when x is equal to 3 and z is equal to 7. So, y is equal to 3 times 3 because x is 3 times 7 because z is 7. So, simplifying that, you have 3 times 3 times 7 is 63. Therefore, y is 63 when x is equal to 3 and z is equal to 7. Let's have number 3. The volume of a cone varies jointly as its height and the square of the radius of its base. The radius of the cone is 4 cm when the height is 6 cm and the volume is 32 pi cm cubed. Find the volume of the cone whose radius is 4 cm and the height is 9 cm. So in this case, we will assign variables. So let's have V to represent volume. So volume is equal to K R squared because it varies jointly as the square of the radius. So R squared. And its height, H. So this is now the formula. V is equal to KR squared h. Again, r is the radius and h is the height. Now we will substitute volume 32 pi to v, and then 4, which is the radius of the cone, to r, 4 squared. And then height 6 to h. Simplifying, 4 squared is 16. So we have k times 16 times 6. 16 times 6 is 96. So 32 pi is equal to k times 96. In order to get k, we will divide both sides by 96. So we have 32 pi over 96. Simplifying 32 pi over 96, as you can see, both numbers are divisible by 32. So 32 divided by 32 is 1. 96 divided by 32 is 3. So simplifying this, we have pi over 3. And this pi over 3 is the constant of variation. Now, since the formula is v is equal to kr squared h, and we know that k is equal to pi over 3, then the equation of the variation is v is equal to pi over 3 r squared h. Now we will use this to solve the problem. And as you notice, this is the formula for getting the volume of the cone. So volume is equal to pi over 3 r squared height. Okay, now we will use this to solve the problem. So v is equal to pi over 3 4 squared. Why 4 squared? Because of this. Find the volume if the radius is 4. So 4 squared. And the height is 9. So h is 9. Now 4 squared is 16. And then 16 times 9 divided by 3 is 48. Or you can have 9 divided by 3 is 3. And then 16 times 3 is 48. So volume is equal to 48 pi cm cube when the radius is 4 cm and the height is 9 cm. Now let's have combined variation. So combined variation is a variation that involves a combination of a direct and an inverse, or joint and inverse variations. So let's have the formula for this. Y is equal to kx over z, wherein again k must not be equal to 0, and k is the constant of variation. Let's have example number 4. Find the equation of the combined variation where y varies directly as x and inversely as z. If y is equal to 4, x is equal to 6, and z is equal to 3, find y when x is equal to 20 and z is equal to 5. So first, we need to find the equation of the variation. So again, let's have the formula. Y is equal to kx over z. 4 must be substituted to y, so 4. And then 6 to x, so that is 6. And then 3 to z. After that, we simplify. 6 divided by 3 is 2. So k times 2 is 2k. 4 is 4. So 4 is equal to 2k. In order to get k, we need to divide both sides by 2. So 4 divided by 2 is 2. So that will be our constant of variation. Now, we substitute 2 to k in our formula. As a result, you have y is equal to 2x over z. And that will be your equation of the variation. Now, this will be used to solve the problem. Find y when x is equal to 20 and z is equal to 5. So we will substitute 20 to x, so 2 times 20, and z must be substituted by 5, so it will become 2 times 20, 40 over 5, so 40 divided by 5 is 8. So y is equal to 8 when x is equal to 20 and z is equal to 5. Now let's have the last example. Given that z varies jointly as x and square of y and inversely as w, and z is equal to 98 when x is equal to 7 and y is equal to 3, and w is equal to 9, find the equation of the variation that describes the relation and the value of z when x is equal to 5, y is equal to 4, and w is equal to 4. So let's start with the equation. Z varies jointly as x, so z is equal to kx, and the square of y, y squared, and inversely as w, w is in the denominator. Now we will substitute 98. After getting the formula, we will substitute 98 to z, so 98, and then 7 to x, that's it, and then 3 to y, that one. W is equal to 9, so w is equal to 9. We simplify this, we have k times 7 times 9, because 3 squared is 9. And then as you can see, 9 divided by 9, we just cancel this. So the remaining now is k times 7, which is 7k. So 98 is equal to 7k. Divide both sides by 7 to get k is equal to 14. And that 14 is the constant of variation. Now we will substitute 14 to k in our formula. Z is equal to 14xy squared over w. This will be the equation of the variation. So we're done with the first problem. Find the equation of the variation. Now let's proceed to the second one. Value of z, we need to find the value of z when x is equal to 5, y is equal to 4, and w is equal to 4. So z, using the formula, is equal to 14 times 5. 5 is x, as you can see. Y is 4, so this will become 4 squared. That's y squared. And then w is equal to 4. So w is in the denominator. So as you can see, 4 is also in the denominator. Simplifying that, we have 14 times 5 times 4 squared is 16. Okay, now dividing this, we have 14 times 5 times 16 divided by 4 is 280. Meaning to say, z is equal to 280 when x is equal to 5, y is equal to 4, and w is equal to 4.